Hello everyone, in today's video we are going to discuss about linear programming under maximization and minimization problems using the graphical solution. Linear programming is used for obtaining the most optimal solution for a problem with given constraints. In linear programming, we formulate our real-life problem into a mathematical model. It involves an objective function, linear inequalities with subject to constraints. Linear programming is a technique used to determine the maximum or minimum value of some quantity based on an objective function. A linear programming problem involves constraints that contain inequalities. An inequality is denoted with familiar symbols such as less than, equal to, and greater than equal to. But due to difficulties with strict inequalities, such as less than or greater than, we will only focus on less than equal to and greater than equal to. In order to have linear programming, we must have first inequality constraints, and second, an objective function, that is a function whose value we either want to be as large as possible, want to maximize it, or as small as possible, or you want to minimize it. So suppose we have to maximize set equals 2x plus 5y subject to the different constraints. So this is our objective function. These are the constraints or restrictions that shape how to attain the objective. And these are the non-negativity constraints, meaning both your x and y have to be greater or equal to 0. So we have the decision variables, the x and y. It tells us what quantity to buy, produce, sell, or transport. And then the word max is short for maximize. So whenever we see an objective function and we see the word max, meaning we need to maximize the objective function. So there is a limitation of graphical method. Graphical solution is limited to linear programming models containing only 2 decision variables. If it's 3 already, we cannot use graphical method. We need to use another software or another application. So this is the graph of the constraints under example number 1 that I already showed to you how to graph using the GeoGebra. So we have the corner points 0, 8, 6, 5, 0, 9, and at 0, 0. So we call it corner points, and the area over here is the visible region. From the corner points, we are going to substitute it in our objective function, set equals to x plus 5y. So in substituting this one, at 0, 0, set is equal to 0. And then 0, 8, we have set is equal to 40. And then at 6, 5, we have 37. And at 9, 0, it is equal to 18. Since we are dealing with maximization problem, we always go to the highest value. So we choose the highest value. So it is 40. So therefore, the optimal point is at 0.8, while the optimal value is 40. Now let us add minimization problem. Z is equal to 15.9x plus 19.5y. So min meaning short for minimize. So we have the constraints also 108x plus 59y less than equal to 5,000 and 15x plus 10y greater than equal to 800. Those are the constraints, and we have the non-negative constraints xy greater than equal to 0. So from that, we have this graph for the constraints, and we have the corner points 0.80, 0.84.7, and then 14.4, 58.4. So we have the corner points already. Now we are going to substitute it in our objective function. So at 0.84.7, the value of our objective function is 1651.65. And at 0.80, the value of our objective function is 1560. While at 14.4, 58.4, the value of our objective function is 1367.76. So since we are dealing with minimization problem, we choose the lowest value. So we can conclude that the optimal point is at 14.4, 58.4, and the optimal value is 1367.76. So let's move on to structure and formulation of a linear programming problem model. So after understanding given problems, we are going to convert it to linear programming. There are two aspects. First, the formulation, and the second one is solution. So example, a company manufactures and sells two types of products, A, B. The cost of production of each unit of A and B is $200 and $150 respectively. So A is for 200 and B is for 150. That's the meaning of the word respectively. Each unit of A yields a profit of $20 and each unit of B yields $15 on selling. Company estimates the monthly demand of A and B to be at maximum of 350 units in all. The production budget for the month is set at 60,000. So how many units should the company manufacture in order to earn maximum profit from its monthly sales of A and B? So the first step after analyzing the problem, we need to make our table. So there are four columns. The first column is for products. The second one is for cost of production per unit. The third one is profit per unit. And the fourth one is total demand. And then after the table, let us represent X as the number of units of A and Y as the number of units of B. And then the total cost is 200x plus 150y. And the budget constraint, we have 200x plus 150y less than equal to 60,000. And for the total demand constraint, according to the problem, it is x plus y less than equal to 350. And let's represent Z equals the total profit. So it will be the maximization or the objective function that we need to maximize. Z is equal to 20x plus 15y. So we have the objective function already, and the constraints are the following. So we have the budget constraint and the total demand constraint. And also we have the non-negative constraint, which is xy greater than equal to 0. From here, we are going to graph. Of course, concentrate on your constraints. So aside from using the GeoGebra application, you can also use the y-intercept as well as the x-intercept. So just make your x be equal to 0 to solve for your y. And to solve for your x-intercept, make your y equal to 0. So this is the graph of the constraints that we have for problem number 1. And from here, we can see that the corner points are 0, 350, 150, 200, and this one is 300, 0, as well as 0, 0. So using the corner points and using the objective function, at 0, 0, it is 0. At 0, 350, it is 5,250. And at 150, 200, it is equal to 6,000. At 300, 0, it is also equal to 6,000. So therefore, the company should manufacture 150 units of A and 200 units of B, or 300 units of A only to earn a maximum profit of $6,000. So let us have another one. This one is under minimization problem. So Safar wants to invest up to $5,000 in his stocks. The share price for the Pitaya Corporation is $108, and it has a standard deviation value of 15.9. The share price of Patana Corporation is $59, and the standard deviation is 19.5. Based on the average of 10-year returns, Pitaya Corporation would produce in a year a profit of $15 per share, and Patana would produce a profit of $10 a share. Sapphire would like to obtain at least $800 in profit. How many shares of each stock should she purchase to minimize the risk as measured by the standard deviation? What is the minimum value of the risk? So your keyword for minimization is the minimum word. So in here, first we are going to make a table and then let X be the number of shares to Pitaya and let Y be the number of shares to Patana. So these are the following constraints. 108X plus 59Y is less than equal to 5,000, and then 15X plus 10Y greater than equal to 800. So let's set be the standard deviation, and for the total standard deviation, set is equal to 15.9x plus 19.5y. So our objective function is set equals 15.9x plus 19.5y. And we have the following constraints, as well as the non-negative constraints. So from the constraints, we already grabbed it. So here's the graph, and then since we are dealing with minimization, we are going to get the visible area here. So we have the corner points, which are the following: 080, 084.7, and 14.4, 58.4. So you can use the GeoGebra here so that you can accurately see the coordinates of the points, of the corner points. So from here, So using the corner points, we are going to substitute it to the objective function. And then as you can see here, at 14.4, 58.4, it produces 1367.76, which is the lowest value. And we will choose the lowest value because we are under minimization problem. So we always choose the lowest when it comes to minimization problem. So Sapphire must buy a whole share of stock. She would buy 14 shares of Pitaya stock and 58 shares of Patana stock. So that's it for now. Thank you for watching. See you again next time. Bye.